Hey guys, welcome to another episode of Building Tensorflow. Today we're going to clean up the sigmoid test. As you can see, currently our implementation works like the operation overloading works, such as that we have to code everything in an assembly language kind of way, like one operation per line. So we want to actually do something like w naught x naught, plus w1 x1, just a bigger, deeper expression. So the way we're going to do that is through operation overloading. So I discovered this really interesting thing that happens. So when you have the way operation overloading works in C++ is that the operation is evaluated from right to left, right? So if you have something like so first g into h will be calculated. This will result in a temporary. So a temporary generally has a const next to it. So this will be a constant tensor. Then that will be added, and then this operation would be called. This would be another const, and then finally these two will be added, right? Right now that isn't possible here. So let me just show it to you what isn't possible here. So let's just copy this and then just do this same sigmoid test, and alright, so if I try to do w1 into x1, then this would be w3. Alright, then we can remove this. Yeah, sorry for that. So where were we? We want to do something like this. Earlier it was like in separate expressions, right? This expression. Now we want something like this. But the problem is that when I run this, keep in mind this is the actual sigmoid test. This is the correct result, and this is what we get when we run the big expression. This expression, this expression, right? So w3 is actually missing. If we print tensor w3 grad, we get nothing. So I'm not really sure of why this behavior occurs, but I found a way to resolve this when I did some digging around. So the problem here that we have is in tensor.h, we're not over. So as I said, a temporary is formed. We're actually typecasting this temporary into a non-const expression, and when we have a const expression, let's see, so we have to override the addition. Let's override it, and we go const here, and here we have and 2. Actually it should be ampersand, and sorry, so that was an error. When we have an actual ampersand, then we get an error, and we get this this error, no operator plus matches these operands, TensorFloat plus TensorFloat. That's because when you construct a temporary, you can't send a pointer to that. You can't send the address of it because it's you actually get a const tensor. So once we add this error goes away, right? But we get another error in the sense of add operation you try to make it, it will probably give an error saying that you don't have a const, invalid conversion from const to this, it's not permitted. So what I try to do is that once we have this const expression, we'll just build a copy constructor which copies the this tensor into a non-const tensor. So let's just do that. Tensor, float, no, tensor t star, let's just call it temp, and then we go tensor t, and then again 2. Well, we actually need to form this. All of it, and we return and then we just return them. Actually we don't need so sorry, this is actually wrong. We just say this. This is just a copy constructor. Right. So that sounds good, doesn't it? That looks good, doesn't it? So once we have this, we have this temp, and then we're just gonna go temp because this is all the pointer, and then that's it, right? And there's one more error here I think that we need to solve. So we're actually saying that this front top should we should get this operation. We're never saying what 2's front top is, and that might be required when we go through the backward pass. So let's say temp front top is equal to this front top. So once we've closed the loop, right, that looks good, doesn't it? Okay. So let's do that for the multiplication as well. We have this, and let's go. Right, that looks good, that really looks good. And then what we're going to do is we're going to do this for the okay, let me just add the comments to loaded functions for each operator on done that. New multiply operation is this 2. Then let's say 2 front door. Front door. So we've overloaded this well, I think. Let's do it for the division too. So this is const. This is. So just copy this. And then this is temp. And then this line. So we don't need overload it for the exponent because actually we can't set, like we don't know whether this as in this object is a const or not. I already checked, and that's actually a thing of contention that we have right now. I'll show you to make it more clearer. So now, as you can see, if you do this, we should get like the same result for both. Cannot convert TensorFlow star initialization. Okay, so this there's one more error. No matching function called to TensorFlow. Const density. Cannot convert TensorFlow to TensorFlow star. Okay, that's weird. Cannot convert. It's in 6641. 66 is where we get the error. So this is the point of contention now. I don't know what the problem here is. Doesn't seem to be a problem here. Oh, okay. Maybe this. Yeah, maybe got to add new word. Sorry. This should be fine now. Yep. So we get the right answer. Right? Both of them are right. There's one more point of contention here, which is we can actually simplify this expression even further. Let's say, let's get these out of the way. At some point we'll also do scalar into tensor multiplication, we'll overload that to get more clarity, so we don't need to write this whole expression. We can just make do with just a 1. I have to look at how that's done. We're spending a lot of time in Shukri's syntax, which isn't exactly what I set out to do when we started this. I wanted it to be more of like, down and dirty implementation of GPU programming, but we just get this out of the way. I don't think we'll spend the next few videos on syntax. We just focus on the functionality for now, and then after a while get the syntax right. So anyway, now we have this great expression, and then what we can do is A into E. So we can do E star this. So we do not need F. We can do A.exp, and then we can actually do something like J divided by G plus H, which will be K. So we got it down to 3 expressions. Let's see if that works. Remember, the top one is the right one. Yep, we got this right. 0.19. That looks all about right. Exactly right. So we got this down to just 3 expressions, our whole sigmoid thing. So that's a big improvement, right? I think so. But the problem, right here is this works, but if I do something like this, star E, so right now the problem is here we're constructing a const temporary, and then we're multiplying this normal tensor by a temporary. So in our overloaded expressions, the right hand side is always a const. We haven't checked if our left hand side is a const or not, and I tried to overload that, but apparently you can't just do something like this. Probably give an error, I think. No error. That is weird. Anyway, so if we have something like this, I have an E here, this gives the right answer, but still not convinced. Let's try to do something simple. So anyway, we got it down to just one expression, something like this. E star exp, and then something like that. What if we try to simplify it even further? Right, and then just add A here. I think we get the same exact answer. Just try to put the limits of this. Okay, we finally got the wrong answer. So this is right, but this doesn't seem to resemble anything like that. So by doing this, I think we're wrapping a temporary const with an exponential. That temporary, I think, essentially disappears after a while. Not sure what's happening here. So anyway, it's obvious that we need to look into how to make this better. Even this, does this make a difference? No, so it's okay. think this does something. This also works apparently. Right. This works. Let's try to do a simple example. Let's try to do something like W0 x1 stop. Sorry about that. I'm actually collaborating with a friend of mine on this very project, and he was just going through pull requests, so that was that. W2, no, that should be W1. Let's make these values more tenable. 2, 3, and let's say W1 and 4 or something. So W0 and 0, 1. Okay, 4, 4, and 5. Is that right? What do you think it should be? So our value is 4 into 5, that's 20. 2 plus 3, 5 into 4, that's 20. 4 star. Okay, so that's 20, of course, and then we should get 5 here as W1, so that's correct, and then we should get 4 here, 4 into 2, 4 into 4 into 4 and 4, that's correct, 4 and 5. That is right. Let's try to do something like this. $12, $8, and 6. And when we do something like this, should be the same answer. 12, 8, and 1. Isn't that weird? And let's try this. This should be 4, 4, and 5, right? 4, 4, and 1. So that's the problem. It should be actually, this should be 4, 4, and 5, same as this. W1 star 4, 4, and 5, and 4, 4, and 1. So let's try to do one thing where we actually, so what operator is this? The multiplication operator. Let's have another overloaded or something. So let's have this. No arguments allowed on user-defined conversion. So this is the error that comes up. Not sure why. No error. Isn't that weird? not getting an error here. Type is missing. Int assumed. Detected during initiation of class. Do you want to debug this? Let's try to debug this. So for debugging, we actually go to our makefile and press standard G for debugging. Then we make this 4, 4, and 5. That's right. Let's actually remake it here. W1. So this expression would be 5, and then so now let's make it again, and then let's debug it. So we go. It's very simple to debug. We just go. Let's debug. Something like Tensor, and then we debug tester. Okay, so let's launch it. Okay, we've got something here. So it's on a plus. So it's on a plus, and it's on here also. So our val here is 2. Okay, 2. I guess 2 val is nothing. Front of is not, we don't know. Let's go ahead, and then it's a multiplication. So this would be a 5 and a 4, right? So 2 val would be a 5, right? This is right. So this is a normal tensor, right? This would be 5, and very interesting. This will be 5, and then this will be a 5, and this should be a 4. This should be a 4, and this is a 4. This new multiply operation, this is good, right? And now we want to actually see what happens in the backdrop. So let's go to operation implementation. Backdrop here, let's put it here so we can see what T1 and T2 is exactly, because now we've actually this T1 and T2 val, and if we go into multiply operation, we put this here. That does sound good, right? This is all good. Okay, let's go, and then here we are. So even in the multiply operation, we're going backwards. So what is T1 exactly? T1 should be 5. Oh, it's 1. Remember, we don't have anything that has 1 in it. We have no gradient, and this T2 would be probably a 4. Yeah, that's a 4. And why do we have a 1 here? We just had a 5 here, right? This should be 5, but we're getting a 1 here. Why is that even happening? Maybe that's because we're just sending a gradient that's 1. We're just doing that. So if you have a backward vector grad and that's 1, and this is just 1, and the gradient front of is T1, this gets an error. I don't know why this gets an error. This should just be back on. This gets an error. Why? I can't see these values. I don't know why I can't. 4. No gradient in front of. Maybe you see this. This is also an error. range. Getting a 1 here. For some reason, when we go to tensor, when we're here, actually gotten our operator, like this is actually a const, is what I'm thinking as of now, and the const just disappears, or it's just a fake variable that's formed. I don't know what the problem is, but you know, you send this here, maybe this ends the while. I don't know what's happening. That is the issue. Because this operator is formed here, and after this operation ends, this just disappears. The tensor that's formed just disappears because the operation has ended. It's a temporary, it's a const, and I think that is wherein the problem lies. This is where it gets confusing. Right. So anyway, we'll try to figure that out after in the next episode, or not in the next episode. I'll try to figure that out on the side, and if I find the answer, I'll address it. But in the next episode, we're going to do some GPU computing, and we're going to bring matrix multiplications in the fold. So I hope you guys have a nice day, and this is where we're at. So whenever we are forming an equation, one rule of thumb is that an actual tensor that we've declared here should always come at the left hand side, and the temporaries, the const, should come at the right hand side. So that's it for now, and we have actually updated our sigmoid test, and now we can actually get this done. Let's remove this. Let's just double check if everything is fine. Sorry. Let's double check that what we're doing is actually correct. This is fine, this is fine, this is fine. Yep, so let's put our updated sigmoid test here. Let's remove all this. And we have officially cleaned up some code, added some sugar syntax to our autodiff. Made it more Pythonic actually. So let's just make it. Alright, yes, we've done it. Just remove this. We'd actually keep this. Alright. Yep. Thank you so much, guys. Sugar syntax added for tensor. Alright, see you next time, guys.